Hello once again. This is Teacher King David. We are still on revision questions about complex numbers. So we are on number 16. Number 16 saying, find the modulus and argument of z. We have z equal to 1 plus I squared divided by 1 minus I. Its bit is saying, show that the representative points in the Argand diagram of the complex numbers. We have the first complex number, 1 plus 6i. The second complex number, 3 plus 10i. The third complex number, 4 plus 12i, are collinear. We have to show that they are collinear. So this is number 15 Lab 2016. So now, for us here, it is number 16. So let us start on A. Our A, question 16A, it is saying to find the modulus of z. Our modulus of z 1 plus I squared divided by 1 minus I. How can you find the modulus of that one? Remember, when you have from z1 over z2, let me say, modulus. This is the same as the modulus of z1 divided by modulus of z2. So again, when you have z power n modulus, it is the same as the modulus of z, then power n. So we're going to use those two formulas. We use those two properties to find the modulus of that one. So now our z is 1 plus I squared over 1 minus I. So what does it mean? So the modulus of z, the answer is 1 plus I squared modulus divided by the modulus of 1 minus I. And you know that when you have when you have z equal to a plus bi, the modulus of z is square root of a squared plus b squared. So which means that the modulus of that z, the answer is from this property, this is going to come square root of 1 squared plus the coefficient of I here is 1, also 1 squared. Then power n, because we have seen that the modulus of z power n is the same as the modulus of that z, then power n. So then our n is 2, then squared. Divided by, so I'm using this property here. The modulus of 1 minus I, it is square root of 1 squared plus negative 1 squared. So our modulus of z is, so this is root 2. Root 2 squared, that is 2. Divided by, this is root 2. So now the modulus of z here, the answer is 2 over root 2 times root 2 rationalize. So we get the modulus of z equal to 2 root 2 over 2, where the answer is root 2. So the modulus of z, the answer is root 2. That's the answer. I hope you don't have any question about A, because I showed you that I'm using those two properties here, and you know the modulus of z, when you have z is a plus bi, is the square root of a squared plus b squared. I hope there's no any question. So let's go to B. B, we have what you can call ZA, because you have points. Or let us first come back on 16A, so you can see it very well. 16A is saying that show that the representative points in the Argand diagram of the complex numbers. So we're going to call this one ZA, we call this one ZB, and we call this one ZC. Then we show that they are collinear. So now, our ZA is 1 plus 6i. Our ZB is 3 plus 10i. Our ZC is 4 plus 12i. So we have 3 points. We have A, B, C. So when does those points, so how are they collinear? So they are collinear. A, B, and C are collinear. If and only if ZC minus ZA divided by ZB minus ZA are a member of real number. I hope you remember that one. So we saw this one in the notes because we studied this one. So now, when ZC minus ZA divided by ZB minus ZA are a member of real number, that's when ABC are collinear. So then, we have ZC, which is 4 plus 12i, minus ZA, which is 1 plus 6i, divided by ZB, which is 3 plus 10i, minus ZA, which is 1 plus 6i. We're going to see if they are a member of real number. So this is 4 plus 12i minus 1 minus 6i divided by 3 plus 10i minus 1 minus 6i. So now the answer is 4 plus 12i. Okay, it's okay. 4 plus 12i minus 1 minus 6i divided by 3 minus 1, that is 2. 10i minus 6i, that's 4i. So then now the answer is 4 minus 1, that is 3. 12i minus 6i, the answer is 6i. Divided by 2 plus 4i. So we can take 3 out of the bracket. We remain with 1 plus 2i. We take 2 out of the bracket, remain with 1 plus 2i. You see this and this one are the same. They cancel each other. We remain with 3 over 2, which is a member of what? Of real number. This is a member of real number. So therefore we say that ZA, ZB, and ZC are collinear points. I hope you don't have any question here, because we just use the formula for the given 3 points. Thank you for understanding this one. Let's go to number 17. So we are on number 17 now. Number 17 is saying that we have 17a and b. So 17a is saying that we have equation z squared minus 2iz minus 5 equal to 0. Give your answer in the form of x plus yi. So we're going to solve this equation. We give the answer in the form of x plus yi, where x and y are real. Then b, find the polar form of each root. After getting those roots, we'll find the polar form of those roots. So this number, it is number 9 Lab 2018. So let's go to number 17a. Number 17a, we have to solve z squared minus 2iz minus 5 equal to 0. So this is a quadratic equation. You know, when you have a quadratic equation in the form of a z squared plus bz plus c equal to 0, you see when you compare this equation with that one, our a is 1, our b equal to negative 2i, our c equal to negative 5. So we can use quadratic formula, where quadratic formula says that our z will be negative b plus or minus b squared minus 4ac divided by what? Divided by 2a. So now z, the value for z will be equal to negative becomes positive, 2i plus or minus negative 2i into bracket squared, because it is b squared here, minus 4. Our a is 1, our c is negative 5. Divided by 2a, 2 times 1, that is 2. So now z is 2i plus or minus square root of, this is 4i squared. I squared is negative 1, that's a negative 4. And this is positive, this is 20. Divided by 2. So meaning that the value of z is 2i plus or minus 20 plus 20 minus 4, that's 16. Square root of 16 is 4. Divided by 2i. Divided by 2. So when it will be 2i plus 4 over 2, where the answer is I plus 2. Then to be 2i minus 4 over 2, where the answer is I minus 2. So meaning that our z1 will be equal to 2 plus I, and z2 will be equal to negative 2 plus I. So those are the roots. Those are the roots of what? Of that correct equation. So meaning that our correct equation, it has negative 2 plus I and 2 plus I. So we are done with A. I hope you don't have any question here. Yeah, thank you. So that is A. B, they are asking us to find, they are asking us to find, B is asking us to find the polar form of each root. Polar form of each root. That's what you're going to do. So the polar form of each root, remember, when you have z equal to a plus bi, you can transform this one into polar form. How do we do that? We say that z in the polar form is r into bracket cos angle plus I sine angle. So where r is the modulus of z, which is a squared plus b squared. A squared plus b squared. Then angle, to get angle, we first get tan alpha, which is equal to b over a. After getting alpha, that's how we get angle. So that's what I'm going to do. Let me start with z1, which is negative 2 plus I. So here, R1 is the modulus of Z1, which is root negative 2 squared plus 1 squared. The answer is root 5. Then tan alpha, that is R1, tan alpha 1 is B over A, or B, that's 1 over 2. We don't consider negative sign. So alpha 1 is tan inverse over half. Then alpha 1 is, so tan inverse over half is 26.6. It is approximate 26.6 degrees. That's alpha 1. So now when you use the calculator, you get 26.6. Then from there, which quadrant? We are in which quadrant there? A, it is negative, but B is positive. So it is here in the second quadrant. We are in the second quadrant. And in the second quadrant, angle equal to pi minus alpha. Pi is 180. So which means that our angle will be equal to 180 degrees minus 26.6 degrees. Where angle 1, the answer it will be, when you use calculator, you're going to get 153.4 degrees. So meaning that our Z1 in the polar form, it will be equal to, because we have R, it will be root 5 into bracket cos 153.4 degrees plus I sine 153.4 degrees. So that is Z1, root 1 in polar form. So what about root 2? We have Z2 equal to 2 plus I. So they have the same modulus, R2 is root 5. So alpha 2 also is, we use the same formula, B over A. So which is 1 over 2. And the answer is 26.6 degrees. So we check the quadrants. That in which quadrant A is positive and B is positive. So they're in the first quadrant, they are here. You know that in the first quadrant, our angle equal to alpha. So therefore, angle 2 equal to 26.6 degrees. So therefore, Z2 will be equal to root 5 into bracket cos 26.6 degrees plus I sine 26.6 degrees. That's the answer. So that is number 17B. I hope there is no any question. So thank you. Let us go to number 18.